And welcome to our virtual science pub, where we used to take science out of the lab and bring it into the pub. But for right now, we're going to bring it to you virtually in your homes. My name is Nathan Moses. I'm the Assistant Director of Events and Engagement at OSU-Cascades, and will be your host for this evening. Tonight's Science Pub, Heceta Bank, Oregon's Hidden Wonder, will feature a very special Oregon State Productions film, which will immediately be followed with a live question and answer session with our evening's panelists. I'd like to offer a special thanks to Connect Central Oregon for their production of tonight's experience. So before we get going, we're going to talk a little bit about audience participation. And just like we did last week, we're going to be using Mentimeter to submit your questions to the panelists tonight. So we're going to, during the presentation, you're going to be able to submit any questions you might have via your smart device or computer at home. To get the app, you're simply going to visit www.menti.com or download it from your respective app store. So we'll get a slide up there for you, but the event code for tonight is going to be 223235. Again, that's 223235, and we'll get that up there in the chat for everybody. So again, apologize for the delays getting started tonight, but we'll make sure we get everybody caught up to speed. So let's get started. Our film tonight, Heceta Bank, highlights Heceta Bank, which is one of the most productive areas on the Oregon coast and a hotspot for biological productivity due to its position and the influence of northern coastal currents in the summers. So thank you for joining OSU marine scientists and our other experts to view this short documentary featuring the submerged bank located 35 miles off of the Oregon coast, and learn about the surprising and beneficial impacts it has on our state's coastal environments. So without further ado, we'll get that video started.
Well, my name is Bill Pearcy. I've been at OSU since 1960. I was one of the 5 founding members of the Department of Oceanography back then. And now I guess I'm a Professor Emeritus in CEOAS, College Earth, Ocean, and Atmospheric Sciences. And most of my research has been on what we call marine nekton, fishes in the ocean, but also squid and shrimp and other things like that. So I've had a really good time here. Great career and a lot of fun.
The rugged coastline near Cape Perpetua is known for its spectacular scenery and abundant wildlife. But the landscape that has fascinated scientist Bill Pearcy for most of his career lies below the water. 35 miles offshore from Cape Perpetua, there is a deepwater bank known as Heceta Bank.
You wouldn't see it, just looking out over the blue expanse. It's one of the most productive areas on the coast. It's a hotspot for biological productivity. We talk about our successful fisheries in Oregon. Heceta Bank is the place.
So it's an extremely productive area because of these 2 things: unique position and the currents coming from the north during the summertime, accelerating upwelling. So it's a very productive area.
Heceta Bank has become one of the most studied features off of the Oregon coast. But that wasn't always the case. In the 1980s, Bill Pearcy became one of the first scientists to get an up-close look at the underwater world of this structure.
And in 1987 and 88, I was privileged to make some of the first submersible dives off Heceta Bank. And it was amazing. It was truly amazing.
Brown above. Yeah, quite here they come in view pretty well.
There was this huge concentration of fish, very abundant, and high diversity. And rocky pinnacles on top of that bank were just amazing habitats for big, what we call macroinvertebrates, things like sponges and crinoids and basket stars just blanketed these rocks, big things like that.
The submerged structure, Heceta Bank, is unique on the West Coast. It transforms the waters around it, driving biological productivity and making nearby habitats thrive. Its effects are felt 35 miles away on the shore and even deep in the coastal forests. It draws birds and mammals from across the globe to its thriving waters. You're about to learn the science behind what makes Heceta Bank tick. A unique blend of geology, oceanography, and biology that has shaped a natural wonder unlike anything else along Oregon's coast. The productivity of Heceta Bank is driven by its geology. And to understand what makes it so special, you must first learn about the forces that created the uplifted structure of the bank.
So the way the ocean works is you get the coast, and the bottom drops off kind of slowly, and then it hits the continental shelf break and it just plummets down to the abyss. And the width of that is called the continental shelf. And what Heceta Bank does is it widens that continental shelf to over double the width. So it kind of sticks out into the ocean from the shore.
The offshore area of the Pacific Northwest from Cape Mendocino up to Vancouver Island is a subduction zone. And that essentially means that the Juan de Fuca plate is diving underneath North America. North America is acting like a snow shovel and just peeling all the sediment off the incoming plate and just kind of, just like a snow shovel, just kind of smushing it into a disorganized pile. It's a big attractant for rockfish because they're just rocks everywhere, so it's a very popular spot for rockfish that are looking for cover, and there's sort of a halo around that of where the juvenile rockfish live. But it's also, directly abuts big sandy areas where flatfish and other sort of sand-loving, biota live. And so it's kind of it's a very rich area that sort of has it all.
Geology is the first key to the puzzle of Heceta Bank's productivity. But another major factor is the oceanography, the way the movement of the currents, upwelling, and waves interact with the physical structures. The first documented mention of the bank came from Bruno Heceta, a Spanish explorer that gave his name to the structure. Heceta Bank, or Heceta Bank as many fishermen and scientists now call it, was first described by the captain for the noticeable change in the watercolor. This was likely due to the high levels of chlorophyll, which jump-starts the whole food chain.
The color of the ocean is very obvious that this is an area that has more plankton. If you're in a commercial airline flying down the coast, you're gonna see it. We fly satellites that can measure the actual chlorophyll, and there's a big pool sitting over the bank. It's Heceta Bank and Stonewall Bank. We call that the Heceta Bank Stonewall Complex. And it's that area where you see high amounts of chlorophyll in the water from phytoplankton blooming. We see a really productive upper ocean where fishermen can go out and catch fish. So it's this special area. And the reason it is special is because of that underwater topography and the way the currents interact with it. But what's amazing is the amount of structure that's there, both in the vertical, different layers, warm waters, cold waters, productive waters, not so productive. And then further, there's this set of currents that are being swept around the banks, and it's just a swirling, active area. So we know a lot about upwelling, how the wind blows and it brings up cold water from below and those nutrients. And what the bank does is it restructures that, and it actually enhances that upwelling in that area. So over the bank, we know there's a bigger area of colder water, a bigger area of nutrients, and a bigger place for plankton blooms. As that southward flow comes barreling down the coast, it encounters this obstacle, which is the bank. And oceanic flows don't like to go over things because the water's layered, and it just takes too much energy or momentum to go over something. So what it does is it goes around the outside, and the bank presents that obstacle. Because the bank is wider and the flow goes around it, it actually amplifies the upwelling. So there's more cold water in a bigger area over the bank. And you can see in these satellite images, there's a big cold part over the bank. And that cold water's come up from below and it's full of nutrients. And it's just the perfect recipe for a phytoplankton bloom. And it happens right over the bank there. And you can see it spreading out from the coast. It goes out 40, 50 miles, and it squirts offshore with all this rich plankton mass. So in this image, we're using bright reds to indicate where chlorophyll is high. With your naked eye from the coast, what you'd see is this green-brown water, this sort of soup. That's all good stuff. This is the plankton that's at the base of the food web. So that same wide area temperature is covered with plankton. It's a big, wide area. You can see in the bright reds here, it swirls around the bank. In fact, some of that water gets shot offshore and is providing nutrition or plankton to the offshore communities.
And that's the water that's so rich in nutrients that starts the food chain. First with phytoplankton, little plants that need the nutrients and carbon dioxide, and they grow and they get bigger. And then you have little zooplankton, things like copepods, euphausids that eat these little plants. And then they're the fodder for bigger things like little fishes and like anchovy, for example, and sardine, and little rockfishes and juvenile fish of all kinds. And those then are eaten by the bigger predators like salmon, bigger rockfish, mackerel, other species that are common off Heceta Bank.
One of the most fascinating effects that Heceta Bank has on the food web is how it interacts with offshore deep ocean species. In these cross-section charts, you can see concentrations of different sizes of fishes near the bank. Because of this interaction, it creates a virtual buffet of forage fishes for predators of all types.
So here you can see in the top panel at low frequency, near the surface, there's forage fishes like anchovies, herring, sand lance that are close to the surface, and they're usually found just offshore a front off of Heceta Bank. This shows the animals that are smaller, like kriller euphausids, little shrimp-like animals that are about an inch or so long, very abundant off the Oregon coast, in offshore waters. And these animals migrate vertically. They go down in the daytime, come up at night. And when this happens, a lot of times they're wafted inshore, and they get trapped behind Heceta Bank here. They're very, very vulnerable to any kind of predators in here. And besides the euphausids, myctophids or lanternfish are often found in big concentrations right off Heceta Bank.
The oceanography and the geology of Heceta Bank are the engines that drive the biological productivity and amazing diversity of the region. The bank attracts a wide range of species, which in turn attracts the scientists who study them.
Heceta Bank being a rocky, deep-water rocky bank that extends up from 500 meters up to 70 meters, it's within the depth range of many important commercial species and non-commercial species of fish and invertebrates along our coast. Again, you kind of have this change of habitat types as you go from the middle of the continental shelf up onto the eastern flank of the bank and then over the top of this rugged ridge that forms the top of the bank and then down through these boulder and cobble habitats. And as you go from one habitat to the next, you see major shifts in the fish communities.
And when you actually look at some of the footage that the remotely operated vehicles and submarines bring in, you see that thick green water, and you see just thousands of baby rockfish and other organisms there. And one of the things that we discovered working with folks on the coast there is that those fish are a really important food source for a lot of predators, including other rockfish and salmon. So when the Chinook salmon come in, on their way to the rivers, they are chowing down on those juvenile rockfish. And you can see that if you go to the cleaning stations and open the stomachs of the fish as they're being cleaned. And so what that means is that high productivity on the bank is getting transferred all the way up into the coast range. The Chinook are also going south all the way down into California and taking those nutrients that they're picking up off the bank down into the Klamath and the Sacramento and so on. So there's this connectivity that happens within Oregon, but it actually extends all the way down the coast.
So the marine birds are a good indicator that there's food available in that area. Heceta Bank seems to be, a retention area for productivity and relatively high energy transfer up the food chain to marine birds and mammals. And there's oftentimes, I think of it as one of those locations that's sort of an oasis, where when conditions, it might be a low food production year for the birds, and you don't see many birds elsewhere, but they're still in relatively high abundance at Heceta Bank. One of the species that I study are short-tailed albatrosses that nest in Japan. And we put tracking devices on those birds in Japan, and we have tracked them all the way over to the Oregon coast and to Heceta Bank. The influence of the bank is beyond the spatial extent of the bank itself. We see not only high bird abundance and diversity over the bank and toward the outer edges, but also near shore and then also at times to the south.
If I'm looking for birds, I'll go down to Neptune State Park and then look in that near shore. And if we're lucky, we'll see them on the water. And so, of course, what they'll do is, since they feed on forage fish, and it could be juvenile rockfish, herring or sardines, or sand lance, or a suite of species in the buffet. There's something happening on the ocean floor that creates this upwelling and diversity that kickstarts the food web. Birds are here consistently. So to me, it's pretty exciting that you can have these specialists from multiple disciplines zeroing in on special areas.
The gardens are fertilized in the ocean by upwelling. So upwelling is one of the characters that's very common for most of the whale species that we study that are migratory and take place along the California, Oregon, Washington coasts. Offshore here, the Heceta Banks has been an important area most years for quite a few animals, and we have a bit of evidence that the same animals are returning year after year. So I think when whales find something that works for them, they continue to exploit that. Productivity can be very, very different all around the world. And here off the Oregon coast, we get upwelling that's advective from winds that bring cold, nutrient-rich water to the surface, gets it into the sunlight, and makes it more productive for the whole food chain from phytoplankton up to whales. And then you have physical features like the banks, Heceta Banks. So those places have special importance because of the assurance of having upwelled water most years.
The biological abundance of Heceta Bank draws an array of species and the scientists who study them. But the area also draws fishing fleets that come to harvest a range of species in the waters near the bank, as well as those areas impacted by the productivity the bank creates.
We live in a really complex world, and this job is basically the same job it was thousands of years ago, using nets, traps, and hooks to catch this great protein for people and bring it back. That simple mission is something that I enjoy. I feel like I could see where I fit into the planet when we're hauling a trap full of fish or crab. It's a good feeling.
We actually work with a number of local fishermen, and that's the spot they go. You know, they sail out of either Newport or the Florence area, and they go right to that region because they know it's highly productive.
Certainly fish like structure, right? And that's a big structure, right? I think it's one of the biggest structures on the offshore structures on the slope in the fishing areas off the west coast. There's a long history of fishing around the bank, on the bank. The mix of species that's available to the fleet is maybe more available here than other available to the fleet. Because really, for the marketplace, you want to have a mix of species.
I look at a marine chart And I usually get excited because I associate so many good experiences from places I see, and certainly these banks are important. They're part of the basis of the richness of this part of the coast. On the east side of the bank, there's a big horseshoe-shaped area fed by the bank and the richness of the bank. And if the crab are in deep water, you're probably going to find quite a few of them just inside the banks. On the west side of the banks, there's a super steep drop-off. So there's kind of a funneling in the depth curve there. So I think sometimes that's the very best part of the coast that I know of to find sable fish.
Fishermen have long recognized that the banks and the shallow areas that they support around them give them a large area to catch fish. A lot of us that have been treated real well by our industries, I guess, feel like we need to either give a little back or protect what's there or fix what isn't somehow, and do what we can to work with research part of the equation to make it more sustainable.
We've done a lot of collaborative research in this lab, and you realize that first, fishermen know how to catch fish a lot better than scientists do, and they know a lot about the environment and all of the complexities of how our coastal systems work. And so it's really a nice, beneficial relationship when we're able to do that collaborative work.
I've worked with UC Santa Cruz, OSU, NOAA, the state of Oregon, and it's something that I like to be involved in. It's great catching millions of pounds of wonderful wild protein, but I want to also contribute to the knowledge base in some small way.
And I think it's just important that the fishermen and the coastal community and people in general realize how important and productive this bank is to not only the fishing community, but just to the productivity of the Oregon coastal area in general.
While modern fishermen, scientists, birders, and naturalists are drawn to Heceta Bank and the surrounding areas enhanced by its productivity, we also know that the very first humans in the Americas were likely drawn to this same area tens of thousands of years ago.
As sea level is lower, and this happens because to make ice the size of Canada, the water budget comes out of the ocean and lowers the world's oceans. But it would have exposed a tremendous amount of coastal landscape that the people that are ancestral to modern Native Americans would have been living out there, undoubtedly, in this place that's the highest resource area concentration on Oregon's coast. One idea that's pretty popular right now in archaeology in North America is that the first peoples to come into the Americas may have walked and boated their way down the coastline of the Pacific. Now, the evidence for that is very difficult to put your hands on because a lot of it is probably offshore. The banks that are out there, Heceta Bank, the Perpetua, Stonewall banks, these are ground fishing areas that are sort of raised rocky promontories out there. During the last glacial period, as sea level was lower, this would have actually been a small mountain range. So it's a chain of mountains that would have run roughly north-south. And on the east side, on the inland side of it, there would have been a large bay. And this bay is larger than San Diego Bay and smaller than San Francisco Bay. So it sets up these really unique environmental aspects of Oregon's coast that we really didn't understand that much until we started to get into the data and put all the maps together. And then as we've begun to do more of our work with the Nautilus and other vessels, we begin to see into the seafloor, and we're now reconstructing what the river systems are like. We can see actual signatures of river channels, and piecing together this past environment has been really important. And a place like the Heceta Bank has really been a focus for our work so far.
Heceta Bank is now one of the most researched areas on the West Coast. And while there's a lot that we know about how it was created and what drives its productivity, there's still more to learn. And in an era of rapid change that includes ocean acidification, hypoxia, dead zones, and climate change, the data collected over decades on this spot is essential to our understanding of a changing ocean.
So one of the reasons we know so much about Heceta Bank is because of oceanography at Oregon State University, getting out there in ships, making measurements. And it's absolutely imperative that we keep that set of measurements going.
These long-term time series provide some of the most important information we have to look at changes in ocean condition, how that impacts not only these natural resources like marine birds, but also the fisheries too.
So the fishing industry, you want to embrace the kind of science that can give you for planning purposes, if nothing else, right? So I think so. I think the fishing industry is probably embracing the scientific side probably more than ever.
Scientific ecological knowledge and local ecological knowledge are on a merging path. But the changing climate is a big concern. You know, the lowering pH, acidification, the rising temperatures and associated changes with that. We need to adapt to these changes, and I'm certain that the scientific community can help us do that.
Well, I think our initial research was kind of pioneering research on Heceta. And so that is, as I say, very gratifying to see that this is something that we kind of initiated and it's continuing. And quite frankly, I've lost track of everything that's going on there now. It's an area that's sort of bustling with research.
Oregon is an ocean state, and we all identify with the ocean. It does, amazing things for us, and it absolutely stabilizes our environment. It provides food, it provides recreation. It does a whole number of things for us. We need to keep that going and have that be a healthy marine ecosystem. And by making these measurements, we can see early signs of change. We can also learn areas that are special, and Heceta Bank is definitely a special place.
Most of the life on the planet is under that surface. There's incredible diversity. It's huge, but it's finite, and we need to take care of it. It's a great big garden.
You're live. All righty, everybody. Well, that was an absolutely amazing film, and that glimpse into that undersea world is absolutely amazing. So now we're going to transition to our question and answer period with our featured panelists for tonight. We're going to have the members introduce themselves first and their roles in relationship to the project. So we'll get started with that first. So let us get set up here real quick. And what I'm going to do is I'm going to have you guys go through. I'm just going to call you out. And we'll go first with Jack.
Hi there, I'm Jack Barth. I'm a professor of oceanography at Oregon State University. And I've been working off the coast of Oregon for 20 or more years now, looking at the ocean circulation and the water properties near the bank. And just really enjoyed working with everyone on this project and hope you enjoyed it. Looking forward to your questions.
Perfect. The next up, no particular order, and Zoom order as they pop up. Bob, let's go you.
Good evening. My name is Bob Eder. I'm a career commercial fisherman. Been fishing in Oregon since 1973, and primarily focusing in recent years on Dungeness crab and trapping sablefish, but I also have experience fishing albacore, salmon, herring, shrimp, and halibut. And a lot of fun working on this project and working with the scientists on this film.
Perfect, Bob. Thank you for being with us tonight. Bill, let's go you next.
Yeah, my name is Bill Pearcy. I'm a retired biological oceanographer at Oregon State University. I've been there for a long time. My specialty is things that swim in the ocean, like fishes and squid and things like that. And I was privileged to make some of the first submersible dives on Heceta Bank and stimulated this project.
Awesome, Bill. Thank you very much. Let's go, David.
Hi, and thanks everybody for checking out the film. My name is David Baker, and I'm a media producer and science communicator at Oregon State University. And I got involved with this project when I got a call from Bill Pearcy that I've got quite a story to tell. And so my job was to help turn that into the film.
Excellent. All right. And then Loren, let's have you up next.
Hi, everyone. I'm Loren Davis. I'm a professor of anthropology at Oregon State University, and I'm an archaeologist. And my interest in this area is that in the past, this was a different landscape, a different environment, and I'm interested to know more about how people might have interacted with it over time.
Excellent. Loren, thank you very much. And then I think last up, Waldo.
Hi, everybody. Waldo Wakefield. I work at Oregon State University in the Cooperative Institute for Marine Resources Studies. And I also, up until recently, was a NOAA fishery scientist in Newport, working on groundfish science and mapping groundfish habitat, and also studying applications of different fishing gear technologies.
Excellent. Excellent. Well, you all, thank you again so much for being with us in the audience tonight. What we're going to do to kind of get started, everybody, is, again, this is your opportunity to check out the mentimeter.com site, and you're going to input in that information that we've posted on both chat rooms tonight. Your event code is going to be 223235. Again, that's 223235. Or if it's easier for you, go ahead and throw some questions up in the chat for Facebook Live and for the YouTube Live productions for tonight. So as they've got them coming back in, let's start off. And what we're going to do, Jack's going to help me out a little bit in case we get lots of participation. Folks on my end are going to be indicating if they're going to answer or not for the questions, and we'll just kind of take it from there. So bear with us as we go through here. First question coming up, and actually we'll do this one for Loren specifically. How did Native American populations use the Heceta Bank area?
Well, there aren't a lot of deep questions about that in terms of through time, but as we look at what we know about local Native American populations, this was a really important place to people. They would have used the modern coastline and would have also used the nearshore areas farther offshore to fish. But sea level has changed a lot through time over the thousands of years that we're interested in looking at the past. And as this landscape changed, they would have interacted with it probably in lots of different ways. There are times when the banks were actually islands and may have been connected also to Oregon. So that would have set up different opportunities for people to actually interact with the coast there.
Excellent. Excellent. Thank you for that. Another question that's come up is, are there any problems with overfishing or overblooming that could upset the cycle that the film talked about?
Maybe I'll take a first cut, and I'll talk a little bit about what happens when there's a lot of bloom material and it falls down to the bottom of the ocean. Sometimes it can get to the bottom and decay and pull the oxygen out of the water, and occasionally the the oxygen will go so low over the bank right near the seafloor that organisms have to get away from that. So that's something called hypoxia or low oxygen. So that does the balance for that time period. It does shift back and forth, and that's what we're looking at is how that changes over time. And I think Waldo probably on the fishery side.
So I'll sort of follow up on what Jack was saying. So in the National Marine Fisheries Service, the Federal Fisheries Service, and also the State Fisheries Service in Oregon monitor our fish stocks very carefully. And we know that we went through a period when some of the bottom dwelling fishes, the ground fishes, were depleted back in the early 2000s. And so there was quite a response to that from the fishing industry and from the scientists. And there were changes that were made, and the fish stocks have been rebuilt off Oregon, and things are in pretty good shape right now. And it's quite a success story. And so we had a period where some of the fish populations were depleted, and we've been able to move beyond that.
Awesome. And Bob, I saw your hand up there earlier. Was there anything to contribute to that one?
Well, I think I'd like to reinforce what Waldo just said. During the course of my career, we've seen tremendous advancement in how the fisheries off the Oregon coast are managed. And other than salmon, which is an ongoing challenge, our stocks are in great shape. Our fisheries are sustainable, and going forward, things like climate change, hypoxia, those are the big challenges. But we are managing very well. It's all about two simple components: taking to harvest and not damaging the environment while you're doing it.
Excellent. All right. Well, thank you very much for that submitted question. I have another one that I have to give a shout out to Brandy with her 9-year-old kiddo watching on Facebook Live. They're up in Washington, and this particular kiddo is thinking about your all's fields of work, if you will. Any advice for a kiddo on moving toward this field, in particular with regards to the Pacific Northwest? So I guess that could be in a large range of things from what it looked like. So anybody want to pick up that one? All right. Bill, got any thoughts on that one?
I think Jack's a good one to answer that.
Oh, okay. Jack, go for it.
Yeah. Science and math. That's the thing to study.
Science and math, exactly. Very good.
Yeah, right. That's exactly right, Bill. I was going to say stay curious.
Yeah.
And walk to the coast and look out over the ocean and think about what it looks like with the different colors, how the winds interact, watch the tides go up and down. And as Bill says, take the science and math classes and you'll be all set. I should, having said that, we're starting a new program at Oregon State called Marine Studies that basically anybody that wants to work in a marine environment, whether they're an economist, somebody that wants to, as Loren does, and studies the ancient people, natural scientists, business folks, anybody, it's in the coast are such important things to the future of our planet that we're trying to welcome just about any student to come join us at Oregon State.
Oh, that's great. And I think actually that stay curious piece, I love that the most, because I think, taking your time and to just observe the natural world, something I know with my own 9-year-olds, Brandy, that's something that we try to enforce on them. So David, actually one for you, got a kind of a comment and a question for this, but general comment is the film is beautiful. And as they're describing, patiently paced. Was there some intentionality with the way in which the film was produced?
Yeah, it's always a challenge to translate science into a video because you can't really pause. You know, if you're giving a lecture or something, you can point something out in a slide, you can interact with the audience a little bit in the classroom, but when you're conveying scientific information in a film, you need to leave a lot of breathing room so that all this information that you're throwing at your audience has time to process, and also that so that it doesn't conflict with the images. The images kind of reinforce what you're hearing. So you always try to be deliberate, and that's kind of my role, not being the scientist in the group, is I try and teach myself this stuff through the medium, and then hopefully that I can kind of stand in as the advocate for the audience when we're putting a film together.
Excellent, excellent. Yeah, and again, just beautifully done film. I'm so happy that we get to enjoy it again tonight, and we will have this posted post-event that you can share with your friends as well. So definitely encourage you to do so. Got a question over here on the YouTube live chat. Would the Heceta head be destroyed in the event of the Cascadia subduction zone earthquake? So is there a kind of a relevance to the location of the Heceta Bank in regards to that?
Who wants to try that one, Bill?
Bill's laughing on that one.
Yeah, we need Goldfinger here. You know, Chris would be a good person to answer that, and he was on the video too, in talking Heceta Bank.
Well,
So,
Waldo here. I'll take a. I need to raise my hand.
Oh, go for it, Waldo. Go for it.
Well, I mean, I would just, you know, there are landslides that happen, submarine landslides that happen, you know, in areas around Heceta Bank when there are earthquakes. And so if there was a large subduction zone earthquake, there would be underwater landslides that would happen in that area that would really change the terrain in that area. In fact, some of those also can be part of the cause of tsunamis that happen. So I mean, it's a good question to ask about what happens when there's one of these large earthquakes, and in fact, you can see where there are large slumps that have happened in those areas from thought to have happened from quakes.
You're talking underwater, right, Waldo?
Yes, where you'd see chunks of the shelf break area that actually have slid down, and they leave these scars. As a biologist talking about geology.
All right, excellent. And anyone else have a comment on that one? Okay, you come back if something sparks you. Next question is this participant through Mentimeter saying, this may be a loaded question, but what is your favorite part of conducting research along Oregon Central Coast?
well, I will answer that because I made a lot of the dives there. And making dives on Heceta Bank was just a revolutionary experience because all the big invertebrates and fishes and things like that is spectacular, like diving on a coral reef. So that was really, you know, a highlight from my career, diving on Heceta Bank in those submersibles.
I would add that for me, and following up on what Bill was saying about actually being able to dive and look at things directly, is to be able to use some of the new mapping tools that we have that geologists use, where you can develop these high resolution maps of the seafloor. So you can actually see the seafloor and the terrain as if the water had been, you know, stripped away. And then to be able to dive on those areas in the submarine to sup both the geology and then also all the biological things that are going on. So using those two tools together, I think for me is just this wonderful opportunity.
For me, it's being out at sea and kind of seeing that connection between the bank area and the land. We saw in the film when Paul Engelmeyer was looking at the bird populations there, and we were talking about the fog coming in off the bank. So to be at sea measuring there and have the land appear out of the fog bank is just stunning. And that connection that we have between the coast and the bank area.
Excellent. All right. Let's see here. Looks like question for Loren. Underwater landslides or movement affect the preservation of underwater archaeological sites?
Well, as yes, it probably would be pretty destructive. I would think that a place like the Heceta Bank area might preserve sites in some places, but in other places there may just not be any evidence left over. The waves that come in can perhaps move sediment cover around that expose or deeply bury sites. And when we do get Cascadia subduction zone earthquake events, I'm sure there's just a marine cover that might underneath it, you might have archaeological sites perhaps. And these are big questions that we're trying to research aboard ships offshore, where we image and try to reconstruct the landscape that used to be out there during periods of lower sea level. So during the last glacial period, to make ice the size of Canada, the water comes out of the oceans. And in doing so, it lowers sea level dramatically, about 300 feet or so. So that would have created a big landform of Oregon that, as sea level came up later in time, it may have destroyed sites or deeply buried them or whatever. It's a huge challenge for us.
Mhm. All right. Excellent. All right, Bob, I'm gonna put you on mute here real quick. All righty. So actually, came in. Bill, you got people really interested when you talked about those dives. Can you talk about what the most memorable experience you had while diving?
Well, a bunch of them. One that I remember very distinctly is going down in some of the first submersible dives, about 80, 100 meters, something like that, depth. These huge school of yellowtail rockfish, maybe 50 to 100 fish. And they followed our submersible. They thought we were the big mother fish. And went around the submersible the whole time and followed us all around. I thought that was just great. So that was, I can still see in my mind all those fish swimming around there. So that, and just the color and the invertebrates, the massive numbers of big invertebrates on the rocks is really spectacular.
Excellent. All right, so another one here coming in. Looks like David, actually to you. What are the biggest challenges in conveying scientific information to a general audience? That's a really good question.
So one big challenge we have is trying to make it relatable in that short form. And one way to do that is through people and introducing characters. And sometimes when you're working with scientists like to have the data do the talking. And the reason that I think people like science pub events is because they get to connect with the individual, with the scientist, and hear some anecdotes and hear some stories. So we used Bill as our character, and it might have been a little reluctant, and he had this great old car, and we thought, let's just follow you to the coast. Let's take a ride in your car and show a little bit of your personality. And as you can imagine, for scientists, that's not always obvious, why we're doing that. But I think that really helped us establish Bill as sort of a character, since his career has overlapped a lot with this place, and we kind of merged Bill's story with the story. So that's how we overcame that issue. So I think it's always, even in a documentary or a scientific piece, just like as in a narrative film, I think casting and character is an important part of the equation.
Excellent. And another one, let's see. So actually this one is, Waldo, this one came up because I know a couple of you were talking about not only the fishes in the area, but also the invertebrate population. What are some things that we know about the invertebrates in the area?
Well, Bill sort of alluded to this a little bit too. One thing about the invertebrates on Heceta Bank is because, and it fits in with what Jack was also talking about in the way that the currents are interacting with the bank. There's a lot of invertebrates that are on Heceta Bank that are they're filtering invertebrates that are filtering particles out of the water, and they're both filtering organic particles and they're filtering small plankton out out of the water as well. And so you have a lot of different kinds of filter feeding invertebrates, like crinoids and deep sea corals and sponges, basket stars that are quite striking. They're sort of charismatic, larger invertebrates that you see on the bank. And they're often termed structure forming invertebrates because they form a structure above the actual rocky substrate. And you don't see that type of invertebrate assemblage when you're out over a sandy or a muddy seafloor. So the invertebrate community on the bank, a lot of it is comprised of these larger, more conspicuous invertebrates that are filter feeders that are taking advantage of being of the way the bank is up in the currents and water's passing over them, with bringing food to them. So many are attached permanently, or sometimes they're attached for short periods and move around, and then they're filtering their food out of the water.
Excellent. All right, excellent. Let's see. There was another one here. Oh, okay. This is actually one for Bob. And Bob, I'm going to go ahead and unmute you here. But it looks like question is, having been on the water for as long as you have, what's the largest change you have seen in Oregon waters?
That's a good question. There's a lot of large changes. The biggest change that we're concerned about is the climate change that's happening. But I think one of the changes that I've seen that has really impressed me is the attitude of my community of fishermen towards the resource. Over the years, there's been an elevated sense of stewardship that's really meaningful to me.
Excellent. Excellent. And then anybody else, just I know that was directed to Bob, but anybody else want to make any comments on that one or have any other thoughts on just changes even as you've been researching the area, anything along what Bob was talking about?
I might just say a few words about the climate change that Bob's talking about. And this is mostly through something we've been calling a marine heat wave, you may have heard about over the last few years. So we've had some warmer than average surface waters come into our area. Normally those are held offshore because that upwelling comes up and pushes all that warm water offshore. But recently in the North Pacific, it's heated up by quite a bit, as much as 10 degrees Fahrenheit. And that water can make it all the way back into shore when those upwelling winds relax. So in late 2014, we had a buoy out there measuring temperatures, and the water went from sort of a typical chilly Oregon summer ocean, maybe somewhere around 55 degrees or so Fahrenheit. It just shot up within a few hours to nearly room temperature, 68, 70 degrees Fahrenheit. And something you'd really notice, imagine changing the temperature in your house that quickly and that much. People notice it when they're going swimming, but more importantly, the ecosystem feels that shock. And it kind of provides a warm blanket over things such that we don't get as much mixing down into the water. And we can also generate lots of plankton blooms. And so it's sort of a jolt to the system, and we're seeing these marine heat waves more frequently now as we think as an indicator of change we're seeing out there.
Excellent. Excellent. All right, another question coming in from YouTube from Mark. Looks like, and this is a longer one, Mark. Thank you for the question, but bear with me. Cape Blanco also seems to have large eddy of upwelling, colder temperature water southeast of Port Orford. I assume that is due to the currents and how far out the Cape protrudes into the ocean.
I'll take a crack at that one. That's something I spent some of my early career researching, and absolutely right. It's Cape Blanco sticks out quite a ways. It's the furthest west point on the continental U.S. And it does shove the currents offshore out into what we call the California current. But if anybody's ever been down to Cape Blanco or Southern Oregon, the other thing is the wind blows like hell down there. So with that extra upwelling, it just really brings up that cold water. So there's at least two things going on at Blanco, and it's a divide almost between Central Oregon weather and oceanography and that we see further south down off Northern California.
All right, excellent. And then Loren, let's see, going back to you, just kind of in your field and what you've been working on, what are some things that you've noticed that have been some of the biggest changes in the area over time?
Well, as I mentioned before, the change in sea level that's happened since the last ice age is very significant. So over the last, let's say, 23,000 years or so, and this is all based on a lot of published evidence that geologists and oceanographers, marine scientists put together that's relevant to archaeology. But what's amazing to me is what the landscape of Oregon's central coast looked like in the past and how it changed. And I mentioned before that Heceta Bank and the Stonewall and Perpetua banks that are out there now used to be part of a terrestrial landscape. So if you lower sea level down to where it was closer to the last glacial period, you have those banks standing up as sort of low mountains, and they would have made sort of a north-south chain. And then as sea level comes up, they change from a mountain range that was connected to the coast to eventually turning into islands. And then 1,000 years ago or so, they become entirely submerged. And so as people have been in this landscape for such a long time, that is Native American peoples, they would have experienced and seen these changes as they occurred. And they would have interacted with the ocean in ways that are really different than the way we understand it now. So I think if anything, when you go to the Oregon coast and you're there, I mean, you can see changes happen at tidal scales on a day, but it's a super dynamic place. And for kids and other people that are interested in learning about oceans, it's a great laboratory for understanding dynamic change environmentally, geologically, and so on.
Excellent, Loren. Thank you very much for that. Getting a couple questions in here. And again, we were talking about this earlier, but just even from the name of the region, I know different groups call the region different areas. Is there kind of a way that you want to talk through that when people question Heceta versus Heceta versus other pronunciations of the area? We've had that question a couple times, so. Bill, hold on real quick. We'll get you here real quick. You are muted right now. Here we go, Bill. Go ahead. Go for it.
I was just going to say that according to Bruno Heceta, back about 1775, when he discovered the bank, that should be the real name, Heceta Bank, without pronouncing the H. Heceta, Spanish, because he was Spanish, captain of that ship, and cruising north to make sure the Russians weren't going to take over the whole country. So, and the Heceta started with a fisherman. And I don't know why that's the case, but it's just stuck. And it's one of these things like in the dictionary, after a while you get new words coming in the dictionary that weren't valid before. So most people on the coast call it Heceta, but it really should be called Heceta Bank.
Thank you for that. Thank you for that. And thanks for those questions, everybody. Next up looks like one for Waldo. So regarding Heceta Bank, are there any current protections on the area that you can talk about?
Well, there are protections in the sense that there are a lot of different sort of management actions that are in place, having to do with regulations about the ocean and in terms of its use and extraction of resources, whether it's oil or gas, or commercial fishing or recreational fishing. So there are a lot of regulations that are in place to protect the environment, along with a lot of monitoring that gets done to be sure that we really have a good understanding of sort of where we're at. There are some specific things that have come into place in the last 20 years that have regulated some spatially where some different types of fishing activity can occur. So banks like Heceta Bank and Stonewall Bank are closed to bottom trawling, for example. So that's one protection that's in place. And there also are fishing gear sort of restrictions that, again, are spatially explicit in where certain fishing gears can be used. And so those are just some examples. So there are protections, and these things are always being looked at and reviewed, particularly through this integrated group that are involved in the management of fisheries called the Pacific Fisheries Management Council, where you have commercial fishing industry representative, recreational fishing, the state and federal agencies, and a lot of other groups that are involved and meet regularly to examine where we're at with our understanding of the ecosystem in places like Heceta Bank, and then to always be, re-examining where we are with our management. And I think it's an extraordinary thing that happens through this fishery council and the way all these different constituents get together on a regular basis and review the science and the management. People along the West Coast should feel really good about that type of thing. And our current situation with our healthy, sustainable fish stocks are a result of that.
Excellent. Thank you. And makes me feel better. Another question that came from YouTube Live. Looks like Greg. This is kind of hitting on, again, some of the climate change pieces that we've spoken to, so maybe this is directly to Jack first. But are there adaptive management actions that can help to minimize the effects of warming on the productivity of Heceta Bank?
I think the biggest thing is us knowing what's out there and how it's distributed. So that's where a lot of both the scientific sampling and the fishing records and Bob Eder mentioned the knowledge of the fishermen being out on the water. So the better we know where things are, we can kind of imprint climate change effects. And something we've been looking at, those low oxygen zones, where do they form relative to where the good fishing is, or do we need to think about those management actions that Waldo was just talking about? But it really all starts with knowing what the bottom looks like, the habitat, knowing what is in the water, and where those climate change effects might happen first.
Excellent. All right, Jack, thank you for that one. Looks like going through for Minty here. Looks like we've got another one here. Relative to sea level, do we know what elevation above sea level Heceta Bank would have been? If we don't know, do you suspect it would have been really steep or relatively low profile? Scan through real quick.
Well, I can say something about that.
Go for it.
And this is also something that Loren was talking about as well. I mean, we do have these high resolution maps of the seafloor now, and you can actually, in a sense, like run a reel back in time and look at where sea level stand would have been back in time and see how that relates to what the bank area would have been like, for example, during the low sea level stand, which might have been 400 feet below what it is now. It's not that it's more complicated than what I just said, but that's a pretty good representation. And so we do know, and when you look at the bank, you can see on the west side of the bank that there are actually remnants of old headlands that were sticking out. And if you look at some of the almost like cartoon images that have been made, or sort of virtual reality images that have been made of the bank. You can actually make one where you're standing offshore and looking at these terraces and cliffs and headlands on the west side of the bank, as if you were looking at it from that time when sea level was at its lowest point. You can also imagine how the ocean was interacting with the bank and whether it was an island or connected to the mainland at that time. And imagine the erosional processes, for example, with waves crashing against this shoreline and at different sea level stands over time that would have affected the shape of the coastline there.
Excellent, excellent. Thank you for that one, Waldo. And it looks like we're kind of getting through all of our question, guys. Looks like here, you know what? That's actually all of our questions. We had a lot of really great questions tonight. Guys, is there anything else as we're kind of approaching that 7:15 time period? I guess parting words from the experts here to kind of close out tonight's evening. Oh, Bill, real quick. Bill, start you over real quick. Sorry, I had to unmute you again.
Okay. This is sort of, something stimulated both by Jack's recent answer and Waldo's. Heceta Bank is not a uniform structure. And there are various habitats going from the top rocky boulder habitats down to 300 soft bottom habitat. And each one of those habitats has a different community of invertebrates and vertebrates. And some monitoring has been over time. So if we're looking about changes in climate and how that's going to affect things, I think it's really important that we have monitoring programs that look at these various habitats, not the whole bank, habitat by habitat, see how structure changed over time and space. And that would give us a clue how fast things are happening, maybe a lot more rapidly on the shallower habitats than the deeper habitats. But I think monitoring the Heceta Bank is an important thing for the future, and we should pursue that as best we can.
Excellent. Bill, thank you very much. Anybody else up? David, I guess we'll end with you then. Is there, for you, we've talked a little bit about, especially from Bill's dives, what his favorite part was, but this film, what was the most memorable thing for you, or what was your favorite part of this project?
Well, I'm really lucky because for a living, I get to talk with a lot of very smart people. And it's so fascinating that this particular spot on the map, you can peel back like an onion. You can talk to somebody who's an expert in birds, in mammals, in geology, in oceanography. And just the layers of a certain spot and the way that you can dig into a piece of the landscape. And in Oregon, we've got so many places like that where you can take a look at something and learn about the past and the history and also learn something about the future. We're dealing with a changing climate, and Heceta Bank is going to be able to tell us some things about how to respond to that. So for me, I always enjoy with all of these projects just that ability to talk to so many different experts and bring them all together from their various disciplines. And this certainly is a spot that has a lot to offer in that way.
Excellent. Well, you guys, again, on behalf of Science Pub, I really appreciate your time tonight. Again, the blood, sweat, and tears that went into all of your research and the production of this film. I think it's an amazing piece for Oregon State University, and just really appreciate your time on the project and definitely with us tonight. So those of you that weren't able to catch us live, we will be rebroadcasting starting tomorrow. You can check out OSU-Cascades Facebook page on our live page. It will be posted there, and also from our YouTube channel from our live feeds. So again, I want to thank everybody else for participating again tonight, and a lot of great questions. And let's stay curious as we learned tonight. And you guys, wish you the best of evening. Again, thanks for joining us.
Thank you. Really appreciate it.
Thank you.
Thank you, Nathan.
Yep. Thanks, everybody.